Hello students, welcome to JSM Learn. In today's video, we are going to discuss some of the previous IIT JEE Main questions and their solutions. So from the chapter Thermodynamics, particularly from the concepts first law of thermodynamics and applications of work done. So previously we have solved related to the same concept some of the questions. Now this is the part B. So let us see remaining questions also. So in this question they have given the information. So first one, list 1 and list 2 thermodynamic process they have mentioned and magnitude in kilojoules. So here beware of units, dear students. So now let us see work done in reversible isothermal expansion of 2 mole of ideal gas. Okay, reversible isothermal expansion 2 mole of ideal gas from 2 decimeter cube to 20 decimeter cube at 300 Kelvin. Temperature also they have mentioned. So now for this you can see work done in this process. What is the formula we can write? W is equals to minus nRT ln V2 upon V1. V2 upon V1. So by using that formula, if you write all these given information, number of moles, 2 moles they have provided, and it is expanding from 2 decimeter cube to 20 decimeter cube. V1 value and V2 value also they are given. Number of moles is there, V1 and V2, and temperature also they have mentioned here. So directly by substituting all these values, so now we can get this value. Let us see, W is equals to minus N value is what? Number of moles 2 they have given. R value 8.314. Why? Because in kilojoules they are asking. Multiplied by temperature they are given as 300 multiplied by ln V2 upon V1. V2 upon V1. V2 is 20 decimeter cube and V1 is 2 decimeter cube. So that means 20 upon 2. Okay. On calculation of this whole value, you will get the answer as 11.5 students. So simplification, on simplification we will get the answer as 11.5 kilojoules per mole. Okay, so for this A we got Q as correct one. For A, Q is the correct one. Now let us see the B. Work done in irreversible isothermal expansion. Irreversible process. So in case of irreversible, what is the formula we will use? W is equals to minus P external into V2 minus V1. Let us see. Irreversible isothermal expansion. 1 mole of ideal gas from 1 meter cube to 3 meter cube at 300 Kelvin against a constant pressure of 3 kilopascal. So here, so if you observe initial volume V1 and final volume V2, here the pressure also they have mentioned. Okay, against a 3 kilopascal means external pressure also they have mentioned 3 kilopascal. So on substituting all these values, so let us see. W is equals to minus P external they have given here as what? 3 kilopascal multiplied by V2 minus V1. V2 is what? 3 minus 1. So here we are going to get the simplest one. So 3 minus 1, 2, 2 3 is 6. So for this R is the correct answer you are going to get. Okay. So for B, R is matching. Now, let us see the C case. Change in internal energy for adiabatic expansion of 1 mole of ideal gas with change of temperature. They have given here 320. So, in case of adiabatic conditions, we know that Q will become as 0. And here they are asking for change in internal energy. So change in internal energy, here the expression is what? Delta U is equals to NCV delta T. Now here we have the value, number of moles is 1. CV value they have provided as 3 by 2 R. So here on substitution we will get N value 1, 3 by 2 R multiplied by delta T is how much? 320. So here I am substituting the value of R also as they are given in kilojoules all the expressions. So multiplying by 8.314 multiplication of what? Delta T they have given here as 320. So this one we are going to get it in joules. So to get it in kilojoules, we are dividing this one by 1000. So on this, you'll get this value as 4. Simplify this one, you'll get it easily. So now delta U value is matching with 4. P. So C is matching with what? P. So now the next one, final one, change in enthalpy at a constant pressure of 1 mole of ideal gas. So again, here they are saying what? Change in enthalpy at constant pressure. As we know, at constant pressure, delta H can be expressed as what? Delta H is equals to NCP delta T. So here, Cp value is here 5 by 2 R, and change in temperature value is 337. Number of moles also they are given as 1. So on substituting all the values, 1 multiplied by 5 by 2, R expression I am writing as in joules, R value is 8.314 upon 1000 I am dividing to convert into kilojoules value. So C P value and delta T is 337. 337. So on simplification of this value, you will get the answer as 7 kilojoules. 7 kilojoules. That means here D is matching with S. D is matching with S. So let us see QRPS. QRPS. So here option D is correct one. So like this you can solve the question. So let us see the next question. Here one very interesting application based question is there. So a cup of water which can be considered as system at 5 degrees Celsius is placed in a microwave oven. So microwave oven. So inside a microwave oven, a cup of water is placed. A cup of water. A cup of water is placed. So now for 1 minute, during which the water begins to boil. So water starts to get boiled. So whenever it gets boiled, okay, liquid water starts to convert into gaseous vapors of water. H2O molecules will be formed here. So now among all these, which is a suitable one? So here inside the micro oven, okay, a cup full of water, cup of water is kept it here. So on boiling this, so liquid water is going to gain the heat energy from the surroundings. It is surroundings means from the micro oven it is gaining. So this is the R system which is gaining the heat energy. That means Q value, heat is absorbed. So Q is equals to positive. As a result of it, by gaining the heat energy only, the system, cup of water is getting boiled. So water vapor is going to formed. So work now done by the system. So work is done by the system means W is, we are going to get the negative value. So as the system is absorbing some heat energy, so internal energy of the system is going to increased. So which is positive. So now let us see here, Q is equals to positive and work done is negative and delta U is equals to positive. So among these, option B is correct one. Q is equals to positive, W is equals to negative and delta U is equals to positive. So like this easily you can solve the questions. So now the next one, let us see. So in this question they are asking students 20 decimeter cube of an ideal gas X at 600 Kelvin. So they have given the information, first volume and at 600 Kelvin temperature and 0.5 megapascal undergoes isothermal, okay, here the notable point, isothermal reversible expansion until until pressure of the gas, okay. So here this one will be considered as P1, so P2 is becoming this one, so temperature they have mentioned. So this is what 20 volume they have given 20 decimeter cube of an ideal gas. So now which of the following option is correct? So here they have provided with log values also, log 2 and log 5 value also they have given. So work done and delta U, change in internal energy and change in enthalpy and heat. So here isothermal process, there is no change in temperature. Delta T will become as 0. As a result of it, change in internal energy will become as 0. And change in enthalpy, delta H also will become as 0. Delta H is also becomes 0. So now let us see. Delta U, delta H, both are going to become 0. So if you see here, in case of option B, where delta U they have given provided as what? 9.1. So that means we can eliminate this one directly. So now let us see which among all these is going to be correct. So now, expansion process. Now, isothermal reversible expansion. As we know, in case of expansion, work done, always we are going to get the negative work. So here, in the first option, they are given here it was plus 4.1 work has done. That means this is for compression work. Option A also we can eliminate like this. Now let us see. So, reversible process, work done in reversible isothermal process is equals to minus nRT. Here they have provided with log values. So I am directly writing this one as minus 2.303 nRT log of. Here they have provided with pressures. So initial pressure P1 upon final pressure P2. So now let us see here. Here they haven't mentioned as number of moles at all. Okay. But temperature only mentioned here. So here you as know this one. So from PV is equals to nRT. PV is equals to nRT. At the place of here at the nRT, initial pressure and volumes can be considered. So what's the pressure here they have mentioned? 0.5 megapascal. So here in this place, pressure and volume. So minus 2.303 multiplied by pressure 0.5 megapascal, 0.5 megapascal. That means 10 to the power of 6 pascals multiplied by 20 decimeter cube. Volume is what? 20 decimeter cube. Means 20 liters. Okay. So now multiplying this one by log of P1 0.5 minus log of P2 0.2. So now let us see. W reversible is equals to minus 2.303. Here the value 0.5 multiplied by 20. If I am writing this 0.5 as 1 by 2, what it can comes? 10. So now look at it. Here they have given the options in kilojoules in these two. You can see kilojoules are the options. So if you write this one, we'll get this one as what? 10 to the power of 6 kilopascal. So here 10 kilojoules, it can be converted directly. So now log of here log 5 by log 2, log A by log B. We can write it as what? Log A minus log B. So as they have provided log 5 and log 2 values. So W reversible is equals to minus 2.303 multiplied by 10 log 5 value 0. Here they have provided 6989 minus log 2 value also 0.3010. On solving this one, W, you will get, on simplification of this, you will get the value as minus 9.1 kilojoules. Okay. So as we have seen, this one is what? Isothermal. Delta U is equals to 0. From first law of thermodynamics, delta U is what? Q plus W. As this term becomes 0, Q will become as what? Minus W. That means heat is absorbed 9 plus 9.1 kilojoules. So now the option which is matching with that, option C is the correct answer in this case. So like this easily you can solve the questions. Thank you students. Follow our channel for more solutions like this.